All right, given an array of strings, we want to find the longest common prefix out of all of those strings. So if we had April, ape, apricot, and append, we would want to find that, or we would find that AP is the common prefix among all of them. And that is what we would want to return, is the string AP. So to do this, we're going to walk through the array. And first we'll go to position 0 and 1, and we will compare April to ape. And once we hit a character that doesn't match, we can stop looking and we can know that the first two characters are what matched. And then we can move on to apricot and ape and see between the two of them looking only at AP. So that if we had a string that was just A, when you go to compare AP and A, we would eventually discover that A is the only common character. So to do this, we will write a function that returns a string. Prefix. And it takes in an array of strings. Okay, and the first thing we want to do is check the array. If array.length equals 0, then we can just return a message. Array is empty. If array.length equals 1, then we can return the one string, because the whole thing would be the answer. And then otherwise we'll get into our algorithm. So we need to keep track of a sub count to figure out how many things are equal to each other, to kind of keep track of that. And then we'll have a count where we kind of use that to determine our loop, so that we don't go over our, like in our cases up here, where we don't go over the two characters. We only want to look at those first two. So the count will keep track of that, and we'll start that at the minimum between the first two elements in the array. Okay, so we've got that. And then we can go ahead and we're going to loop through the entire array. And actually, we're going to loop through the entire array minus the last element, because we can stop when we're comparing like append and an A. We don't want to move on forward after that. So plus, and then first we will look at are they equal. So if array at I, and we're looking at the sub count, which will increase each time, equal to array at I plus 1 at sub count. Well, and you know what? We don't want to just get right into it. We need to actually continue a loop going through. So let's do a while. while sub count is less than count. This is what's going to keep us from looking at more letters than we need to. And we need to make sure that sub count is less than the array length. I mean, not the array length, the string length for both strings that we're looking at. So we need it to be and sub count is less than array at I plus 1 dot length. Okay, so while all of those conditions are true, we'll keep looking at the characters within those first positions we were identifying. So then we can say if array at I sub count equals array at I plus 1 sub count, then we know that we can increase sub count because we want to keep looking at the next set of characters. So sub count plus plus. And then otherwise, if they are not equal, then we can break because we don't need to keep increasing sub count and we don't want to keep going through that while loop for no reason. So after that, we can go ahead and do a little test. If sub count is equal to 0, it means that it never found any matches, which means there are no common prefixes. Okay, and then we want to set count equal to sub count. And then sub count restarts to 0. So this should run through for each string in the array. And sub count will theoretically be getting smaller or staying the same, which would mean that count gets smaller or stays the same through each string. So after all that, we can return, we just want to return the substring that's the common prefix. So it doesn't really matter which word we use or which string out of the array, but we know for a fact there's always going to be one at position 0 since we have a string. So we can use our substring built in, and we want to go from 0 to count. Okay, so let's go ahead and test this out. Okay, so if we have, let's go ahead and remove that, and we can start with some new words just to kind of make sure. So let's say we have spark, sparkle, spar, and spa. So obviously we'll want to return spa. So these are 0, 1, 2, and 3. And let's go ahead and number these just to keep it easier. Okay. So we know we need to keep track of sub counts and count and I. Okay. So first we look if array.length equals 0, which it does not. If array.length equals 1, which it does not. And this looks like a -1, but it's not. It was a double equals 1. Okay. And then we have sub count equals 0. count equals the minimum between array at 0 and array at 1's length. So we have spark, which is a length of 5, and sparkle is a length of 7. So count starts at 5. And then we go into our for loop, and I is going to start at 0. So while subcount is less than count, which is true, and subcount is less than array at I dot length, which we know is 5, and subcount is less than array at I plus 1 dot length, which is also true, then we go in. So if array at I subcount, so if array at 0's 0, so this S here is equal to array at I plus 1 subcount, this 0, then subcount plus plus, so subcount becomes 1. We keep going in our while loop and make sure subcount is less than count, which it is, and we're also less than the lengths of the two strings. So we go in if I at subcount equals array at subcount. So if 1 and the position 1 and 1, which is P and P, are equal, subcount plus plus, so subcount becomes 2. And we can actually keep track of our little arrows just to be organized. And then we go around again, subcount is still less than count, and we are still meeting it being less than the length of both strings. So we go ahead and we go in, and is it equal at those positions at position 2? Yes, A equals A, so subcount plus plus. So now subcount is 3. This was the 0 and the 1, okay. And then we look at if they're equal, so yes they are. So now subcount plus plus, subcount is now 4. Okay, and we go around again. If subcount is less than count, which it is, if subcount is less than array of I dot length, which it is, and the second one it still is, then subcount plus plus. So now subcount is 5, because they're both equal, k is equal to k. And then we go around to our while loop after again, and subcount is not less than count because count was 5. So we go in and break out of our while loop, and we say if subcount equals 0, which it does not, so we do have common prefixes. Count equals subcount. Well, count already equaled 5, luckily in this situation. Subcount equals 0. So we go down, and now subcount equals 0. Okay, and then we go I plus plus. I is now 1. So now we are looking at position 1, and we will end up looking at position 2. Subcount turn to 0 again. Okay, so well, subcount is less than count, which is true, and subcount is less than the lengths of both of the strings we're looking at. So we go in if array at I subcount, so here we are, and here we are, then subcount plus plus, so they are equal, so we add to it. And then we go again, is subcount less than count? Yes, and we have it less than both of the lengths of those arrays. So we go in and we say if array at I, which here on our subcounts, a subcount equals this, so is P equal to P? Yes, it is, so subcount plus plus. And then we go through, and subcount is still less than count. We're still less than both of our lengths. So we go subcount. We were looking at subcount 2. So is A equal to A? Yes, it is. Subcount plus plus. Subcount's now 3. So we go to 3. Okay, and then we go up. Is subcount still less than count? Yes, it is. Are we still less than the length of the arrays? Yes, we are. And then we go in and we say Is array at I subcount equal to array at I plus 1 subcount? So is R equal to R? Yes, it is. So subcount plus plus, subcount's now 4. We go around, subcount's less than count, but subcount is not less than subcount at array at I plus 1, because that one is a length of 4. So we get out of our while loop, and it says if subcount equals 0, which it doesn't, count equals subcount. So count is now 4, and subcount is going to go down to 0. Okay. All right, and now I plus plus, I is now 2, and 2 is less than array dot length equals 1 or minus 1, because that would have been 1, 2, 3, 4 minus 1, so that's a 3. Keep track of that. So while subcount is less than count, which it is, and subcount is less than the lengths of the two strings that we're looking at, and we are looking at spar and spa. Then if array at I, which is 0, array at I subcount that is equal, which S is equal to S, then subcount plus plus. Go around, we're still less than count, we're still less than the size of the strings. So we go in, if our two characters are equal, which they are, P is equal to P, subcount plus plus. We go around, we're still less than count, and we're looking at position 2, and A is equal to A, so we get subcount plus plus, which is 3, and then we go around, and while subcount is less than count, it is, but is subcount less than array at I plus 1's dot length? No, it's not, because that length is 3. So we get out of our while loop. Now, subcount is not equal to 0, so we skip that. Count equals subcount, so count now equals 3. So count goes to 0. And then I plus plus, I is now 3. And then we go up to our for loop. 3 is not less than 3. So we get out of our for loop, and we're going to return A of 0, which is spark, the substring from 0 to count. So from 0 to count. So that means we're going to go 3 spaces. So we're going to return SPA. All right, and the complexity of this is O of M times N, where M is the size of the array, or the number of elements in the array, and then N is the largest length of the length of the largest string. So ideally, we wouldn't be going through every single letter in every single string, but worst case, we could end up doing that. And it takes 0 space. All right, so that should do it.